So hello students. So today we are going to discuss your mock test that has been conducted on 7th June. You all may have attempted it, or those who have not attempted it, so you can attempt with me, and those have attempted it, so they can see the detailed solutions, and let's have a revision class. So you can open this mock test in your Sathee app. So let's start. Okay, so first question is, for a gallium arsenide sample, the current voltage characteristic curve shows. Okay, so we have discussed in our current electricity chapter in non-ohmic devices, characteristic of non-ohmic devices. Okay, so we have discussed three cases, out of which one case is non-unique VI characteristics. Okay, so this gallium arsenide specially we have discussed for non-unique VI characteristics. Okay, so the graph for this gallium arsenide look like this. In this direction there is current, and this there is a voltage. Okay, so the graph for gallium arsenide look like this. Okay, so for a particular value of current, there is multiple voltages, two voltages corresponding to particular value of current. So for I0 there is two values, V1 and V2. Two values of voltages are there. So this is the VI characteristic for gallium arsenide, which is non-unique. Means there is not a unique value of current for a unique value of voltage. Okay, for a unique value of current there are two value of voltages is there on the graph. Okay, so for gallium arsenide sample, the current voltage characteristic curve shows multiple voltages for the same current. Okay, so first option is linear proportionality between V and I, which is not there. Second option is multiple voltages for the same current, which is correct. Third option is symmetric behavior for positive and negative voltages. Okay, this is also not true. And constant resistances at all voltages, which is also not true, because slope is not constant throughout the graph. Okay, so let's see the next question. Heater of electrical kettle is made of wire of length L and diameter D. It takes 4 minutes to raise the temperature of 0.5 kg water by 40 K. This heater is replaced by a new heater having two wires of the same material, each of length L and diameter 2D. The way these wires are connected is given in the options. How much time in minutes will it take to raise the temperature of the same amount of water by 40 Kelvin? Okay, so now you can see we have to raise the temperature of 0.5 kg of water by 40 K, and when we change the electrical heater, again in second condition we have to raise the temperature of same amount of water by same temperature. Means the energy provided is same in both cases. Okay, so energy dissipated, or we can say energy consumed, that is represented by H. It is represented by V square by R T. Okay, so now this H is same in both cases. In first case, when there is a wire of length L and diameter D. Okay, in this case, in first case, R is rho L upon A. Okay, okay, for this heater, H is equal to V square by R T. Okay, so this H is same in both the cases. Okay, so resistance in first case is given by rho L upon A. Okay, so in first case length is given L and diameter is D. Okay, so rho L, what is area? Pi r square, but it is given diameter, so pi d by 2 square means d square by 4. 4 will go in the numerator, so it will become 4 rho L upon pi d square. Okay, so now H is constant. From this first equation, H is constant for both the cases. Okay, we have to raise the temperature of same amount of water by same temperature, so H will remain a constant value, and we have given the voltage supply to this heater, and this voltage supply will also be constant. Okay, we are connecting this electrical kettle across same voltage supply. It is not given, but it is assumed, because they have not talked about anywhere about the voltage, so this will be taken as constant, because if we are connecting this electrical kettle in our home, so voltage will always be 220 volt. Okay, so we are not changing the V, so that means this H and V is constant. That means from 1 we can say this T is proportional to R. Okay, and this T is proportional to this thing. For first T, initial case, for initial case T is proportional to this term, 4 rho L upon pi d square. Now this 4 rho and this pi is also constant, so we can say T is proportional to this L by d square, length and square of diameter. Okay, now for second case, you can take it as second equation. Now for second case, this wire is replaced by two wires of same material, each of length L and diameter D. So now resistance in second case, now resistance will be, resistance of one wire will be rho L. Now what is the diameter? Diameter is 2d square, so pi 2d square, so pi 2d by d. Okay, so 2d is the diameter, so 2d upon 2 square, which will result in rho L by pi d square. Okay, so R dash of one wire will be, what is R? This, so R dash will be R by 4. Okay, so R dash will be R by 4. Okay, so now if we connect this wire, two wires in series, then the R series will be R dash plus R dash, which will be R by 2. And if we connect this in parallel combination, then R parallel will be 1 by R parallel equal to 1 by R dash plus 1 by R dash, which is equal to 4 by R plus 4 by R, which is equal to 8 by R. So R parallel will be R by 8. So these are the two things. R series, if we connect these two wires in series, then the equivalent resistance will be R by 2. If we connect this in parallel, the equivalent resistance will be R by 8. Okay, now T is proportional to R. Okay, so now T is proportional to R. Now for first case, now for second case, T series will be proportional to R by 2, because resistance in series is R by 2. So T series will be proportional to R by 2. So now take the ratio. So it will become T by T series, and T proportional to R, this proportional to R by 2. So it will become 2. Okay, so R will get cancel out. So T series will be T by 2. which is T was 4 minutes. It is given in the question in initial case. So T series will be 2 minutes. Okay, is there any option with 2 minutes? No. Okay, so series combination, it is given 1 minute and 3 minutes. So both these options are wrong. Now T parallel will be proportional to R by 8. So T by T parallel will be 8 R by R. So R will get cancel out and this T parallel will be T by 8. Okay, so this T is 4, 4 by 8 is 0.5 minute. Okay, so 4 minutes if wire are parallel is wrong. What is the correct option? 0.5. 4 D option is the correct option. So we'll mark D option as correct option. Got it? So let's see the next question. The figure shows a portion of an electric circuit. Resistors are known and indicated as on the diagram and the voltmeters are identical. Okay, if the voltmeters V1 and V2 read 7.5 volt, it is reading 7.5 volt, it is reading 5 volt. Okay, find the reading of the voltmeter V3. Okay, so we have to find the V3 reading and we have to write the value in integer. Okay, now you can see current flowing through this wire, take it as I1, current flowing through this wire, take it as I2, current flowing through this wire, take it as I3. Okay, now current, since this resistor and this V1, resistor R1 and V1 are in series, so current I1 will be same for both the components. Similarly, I2 will be similar for both resistor and voltmeter, and I3 will also be same for both R3 and V3. Okay, now we can say the resistance, let resistance of these voltmeters, because all the voltmeters are identical. It is given in the question, voltmeters are identical. So let suppose their resistance is R. Okay, so resistance is R of all the voltmeters. So now the net resistance in the upper section will be R1 plus R. So current voltage, since all the three branches are connected in parallel, this branch, this R1 and V1, this branch, this R2 and V2, second branch, R3 and V3, third branch. So all the branches are connected in parallel. Okay, so potential difference across all the branches will be same. It means net resistance in the first branch is R1 plus R and current flowing through it is I1. It will be same as current flowing through second branch and net resistance R2 plus R, which is equal to I3 R3 plus R. This is correct. Okay, now we can also say the potential difference, the voltmeter is reading, first voltmeter is reading 7.5 volt. It means I1 current is flowing through it and its resistance is R, and the potential drop across this voltmeter is 7.5 volt. Similarly, for second voltmeter V2, current flowing through it is I2 and R is the resistance and equal to 5 volt. We can take ratio, it will become I1 by I2 will be 7.5 by 5, which is 3 by 2. Got it? Now from here I1 will be 3 by 2 I2. Okay, now we will solve for this box and put I1 here as 3 by 2 I2. So I am writing here 3 by 2 I2 R1 plus R equal to I2 R2 plus R. So I2 will get cancelled out and 2 will go there. It will become 3R1 plus 3R equal to 2R2 plus 2R. So 2R will get subtracted from this 3R. It will become R. And 3R1 will go there. So 2R2 minus 3R1. So R2 is given, which is 14. So 14 into 2, 28. Minus 3R1. R1 is given 9. So 3 into 9, 27. Equal to 1. So R resistance of all the voltmeter is given 1 ohm. Got it? We have found the resistance of all the voltmeters. Okay. Now apply this thing, this formula. Now apply this formula or the value found here in this thing. Okay. So now I am writing I2. Now you can find the I1 and I2 from there. Firstly. So I1 here is R is 1 ohm. So from these two things, I1 into 1 ohm equal to 7.5 volt. So I1 is 7.5 ampere. And similarly I2 will be 5 ampere. Now we can find I3 by this box term, this thing. Okay. So I am erasing this. Okay. Now I2 is given 5. R2 is given here. What is R2? 14 plus 1 equal to I3 we have to find. R3 is given 24 plus R is 1. So here which will become 5 into 15 and 25 I3. So 5 5s are 25 and 5 will go there. I3 will become 3 ampere. Got it? I3 will become 3 ampere. I am erasing it. You can note side by side. You can also type answers in the chat box if you have solved it. Now potential difference across this V3 is I3 current is flowing and R is the resistance. So V3 will be I3R. So I3 is 3 ampere and R is 1 ohm. So it is 3 volt. We have found this. Got it? So what is the answer? You can write here now 3 volt. Okay. So let's move on to the next question. Okay, the maximum current that can be drawn from a cell with EMF E and internal resistance R occurs when? Okay, so we have discussed when there is external resistance capital R and there is a battery with internal resistance small r is connected. This is small r, this is battery of EMF E. Okay, or we can say epsilon as given in the question. Okay, so current flowing through that external resistor will be given as epsilon upon R plus R, which is the net resistance in the circuit, and this is the EMF of the cell. So current is given by this. When current becomes maximum? When this external resistor becomes 0. We cannot say internal resistance becomes 0 because there is a battery. We can't remove the battery in from the circuit, and battery will also have an internal resistance, small amount of. Okay, so maximum current is when R becomes 0, denominator becomes minimum. So maximum current will be epsilon upon small r in this case. So when R becomes 0 or R tends to 0, or we can say R becomes 0. Got it? So according to this, what is the option? So I will start asking one by one if you are not answering in the comment section. Okay, so you have to answer, those who have solved, or those who are solving before me. Okay, R equal to 0. Let's move on to the next question. Okay, a current I flows through a resistor R. The power dissipated as heat in the resistor is given by. Okay, so there is a current which is flowing through a resistor R. So I current is flowing through a resistor R. Okay, so power dissipated as heat in the resistor is given by which of the following expression? A option, B option, C option, D option. This is simple. So power dissipated is given as yes. It is given as VI. It is given as I square R. It is given as V square by R. All the expressions are for power dissipated. Okay, so which is correct option? Third option, I square R. So to minimize power loss in transmission cables, which method is employed? Okay, so there is a device which is being operated, which is of rated power P and being operated by the voltage V and current I. Okay, there is a device which we use to operate and its power rating is P, and it is given by voltage supply given to that device and current flowing through that device. Okay, now the source is provided by some distant source. Okay, the electricity or power supply is provided by some distant source, and from that distant source we have to transfer the electricity through transmission cables. Okay, now what method is employed? So we are going to minimize the power loss. So what is the power loss in the transmission wire? I square R. Okay, so from here we can put I equal to P by V. This is the power rating, this is the voltage rating. Okay, this is the power rating of the device that we are going to operate, and this is the voltage rating of the device. Okay, current can be varied. So these two things we are going to put here. So put here in place of P, so it will become P square by V square into R. So this is power consumed or power loss in the transmission cables. Okay, so what we can do, we cannot reduce the power rating, okay, of the device. We can reduce the resistance, but transmission cables are for distant transfer of electricity. Okay, so for great length there can be a significant resistance. We cannot reduce it much. Resistance there can be there. What we can increase or decrease? We can increase or decrease the voltage. Okay, so we can, if we decrease the voltage, the power consumption will increase. So we have to increase the voltage so that this power consumption must decrease. Okay, so you may have seen that there is a power lines with much high voltage like 11,000 voltage. There is a danger signal that of red color. There on danger signal it is written that 11,000 volt or 5,000 volt. Okay, so why this transmission cables have so much large voltage? Because of this, because to minimize power loss. Okay, so to minimize power loss we have to increase this voltage, and at the end where we are going to operate the device which only needs 220 volt, we will use transformer. Okay, we are going to discuss about transformer in our upcoming chapters. Okay, so we are going to use transformer which further decrease the voltage to a safer level. Okay, so what is the correct option to minimize the power loss? We are going to increase the voltage. Okay, next question. A platinum resistance thermometer has resistance of 5 ohm at ice point. Okay, and 5.23 ohm at steam point. If the resistance in a hot bath is 5.795 ohm, what is the bath temperature? Okay, so you should solve with me and give me the answer. So 5 ohm at, so what is the ice point at 0 degree Celsius? And temperature at this 0 degree Celsius is R0, which is 5 ohm. Then at steam point, which is 100 degree Celsius, RT will be 5.23 ohm. Now if the resistance, okay, not RT, it is R100 at 100 degree Celsius. Now at any temperature T, RT is given 5.795 ohm. So you have to determine what is the bath's temperature, and alpha is not given. Temperature coefficient of resistance is not given. We can find the temperature coefficient of resistance from these values. How? Now we know that RT is given by R0 1 plus alpha delta T. This is the expression for temperature dependence of resistance. Okay, now for these terms 100 and 0, we can write here R100 at 100 degree temperature, and this is taken as reference 0 degree, 1 plus alpha, and what is delta T? 100 minus 0. So we can find the alpha from here. So multiply R0 so it will become R0 alpha 100. Okay, so alpha will be R100 minus R0 upon this R0 alpha, sorry, R0 into 100. So this is alpha. We can write here alpha is R100 minus R0 upon R0 into 100. So this is alpha. We know all the values. We are not going to put here. We are going to put at the end. So now I am raising this thing from where this alpha came. I have written the final expression for alpha. Now for this T temperature, we are going to find the temperature at which resistance is this. So formula for this is this. So we can modify this according to this. RT is equal to multiply R0 in the bracket, R0 plus R0 alpha delta T. And we can write this delta as T minus 0. Okay, temperature T minus the reference temperature, that is 0 degree Celsius. Now alpha is given here. So we are going to find the T temperature. So RT minus R naught upon R naught alpha is equal to T. Now we can put this T as RT minus R naught upon, put alpha. What is alpha? R100 minus R naught divide by R naught into 100. R naught and into 100. Okay. Now R naught and R naught will get cancel out. So T will become RT minus R naught upon R100 minus R naught and into 100. Okay. So put the values. RT is given? No. RT is given? Yes, given. 5.795. R naught is given? Yes, 5. Upon R100 is given 5.23 minus R naught is given into 100. So after solving, you will get 345.65 degrees Celsius. Got it? How to solve? So this will be the answer. So next question, which material is most suitable for manufacturing standard resistor due to minimal temperature dependence of resistivity? Okay, we know that alloys, we have discussed that alloys have minimum value, or we can say very small value of alpha. Their value of temperature coefficient of resistance or resistivity is so small. It means that resistance changes with very small amount with large change in temperature. Okay, so their resistance changes with very small amount with large changes in temperature. Okay, so alloys can be used as standard resistor coils. Standard means their resistances cannot change or should not change much with the temperature. The resistance remain almost constant. So what is alloy here? Which option is alloy? Copper, nichrome, silicon or germanium. Copper is metal, silicon is semi metal. Okay, this is also germanium is semi metal. So nichrome is the alloy here, nickel alloy. So correct option is nichrome. Okay, so next question, how does the resistivity of a semiconductor change with temperature? Okay, we have discussed the behavior of all the materials, and we have discussed the resistivity, temperature dependence of resistivity of all the materials. For conductors, resistivity increases with temperature. For insulators, resistivity, for insulators and semiconductors, resistivity decreases with temperature. Okay, for semiconductor and insulator, if temperature is increasing, their resistivity will decrease. For semiconductors, or we can say insulators. Okay, so what is the correct option here? The resistivity of semiconductors decreases with temperature. Okay, So let's see next question. Which of the following material has highest resistivity? Okay, we know that insulators have highest resistivity and metals have least resistivity, and semiconductors have resistivity in between conductors and insulators. So copper is a conductor, so it will have highest resistivity or lowest resistivity. Silicon is semi metal, so it will have, or semiconductor, so it will have resistivity in between conductors and insulators. Rubber is insulator. Germanium is also semi metal. So which material has highest resistivity? Rubber. Okay. Now, two cells of EMF epsilon 1 and epsilon 2 with internal resistances R1 and R2 respectively are connected in parallel. What is the equivalent EMF? We know that for parallel combination, equivalent EMF is given by epsilon 1 R2 plus epsilon 2 R1 upon R1 plus R2. So this is expression for EMF equivalent for parallel combination of cells. Okay, so which expression is matching this? Which option is matching this expression? First, no. Second, yes. Third, no. Fourth, no. So second is the correct option. So 12th question, which of the following materials or devices exhibit a non-ohmic behavior when the relation between voltage depends on the sign of voltage? Okay, so which device exhibits a non-ohmic behavior where the VI characteristic depend on the nature of or sign of voltage? Okay, we have discussed that semiconductor materials show this behavior, and diode is made of semiconductor materials. Okay, their graph will look like this. So here is voltage V, and here is voltage in reverse direction. So it is called reverse voltage, it is called forward voltage, voltage, and this is reverse voltage. This is forward current, which is in milliamperes, and this is reverse current, which is given as microamperes. Okay, so this is their characteristic, and in reverse direction this is shown as this. Okay, so their behavior changes when we reverse the sign of voltage. Okay, so here the current is very small amount, in the amount of microampere, or in this direction current will be in the milliampere. So what is the correct option? Diode. Okay, so you can see why this is incorrect option, because we have written 3, so they are expecting braces also. Okay, otherwise option is correct. 3 is the correct option. Okay, now we were discussing this question, so what is the correct option? Diode. Okay, so let's see next question. Now in the absence of electric field in the solid conductor, which statement about electron motion is correct? Electron move in a specific direction causing a net current. Electron move randomly with no current. Okay, when there is no electric field, then the motion of electrons in a conductor is random. That is a conductor. Okay, so motion of electron is random. Some electrons are moving in this direction, some are moving in this direction, some are moving in this direction. So motion of electrons are random in the absence of electric field. Okay, so equal number of electrons are moving. Are you able to see the screen? So equal number of electrons are moving in the opposite direction, so they will cancel the current. Okay, so let's suppose n number of electrons are moving in forward direction, so there is n number of electrons that is moving in opposite direction to cancel the current due to forward electrons. Okay, so since the motion of the electron is random, so the net current due to all the electron will be 0 in the absence of electric field. Okay, so other option is electron move in specific direction, which is wrong. Electron move in specific direction when there is an electric field. Electrons stop moving completely, which is also wrong. Electrons move toward positive end, which is also wrong in the absence of electric field. So second option is correct. Okay, which of the following represents the correct order of magnitude for electric currents? Okay, we have discussed in the starting of the chapter, okay, that in our nerves the current is of the order of microamperes. In our houses the current is of order of 1 ampere. Okay, so it is of order of 10 raised to 0 ampere, which means 1 ampere. And for lightning the order of current is 10 of thousands of ampere, we have discussed. Okay, so other options are incorrect. Lightning, first option is saying that lightning is of microamperes, which is wrong. Lightning contains the higher order of currents because it is of very high potential difference or voltage. So domestic appliances, kiloamperes, no. In domestic appliances the order of the current is of 1 ampere. Okay, and fourth option is also incorrect. For time varying current, if the current is varying with time, then the instantaneous current is found by which option? First option is delta Q by delta T. Okay, this is large interval over which average current can be found. Okay, not instantaneous. So after applying, so for average current, it is given that how we found the average current over a large interval, it is delta Q by delta T. If we are going to find the instantaneous current, make this large interval tends to 0. Make this large interval as a point. Okay, so if current is varying over a large time, so this is a large interval, so we are decreasing or reducing this interval to a point. So we are decreasing this interval to a point, which eventually becomes the dq by dt. So this dt is very small interval, which is pointing to a small interval, nearly a point. So instantaneous current, it can be found using dq by dt. This dt is very small interval representing a point. This delta t is large interval, and this it, this expression is showing average current. So this expression is showing the instantaneous current. Third expression is also for steady currents. This expression is for steady currents. So it is also correct option, incorrect option, it is also incorrect option, and this is incorrect expression. So second option is correct. Next question. So in balanced Wheatstone bridge, what is the condition? In balanced Wheatstone bridge, there is R1, there is R2 connected like this. There is a galvanometer here. There is R3 and there is R4. And these all are connected with the battery like this. Okay, so in balanced condition, the ratio of these resistances should be equal. R1 by R2 should be equal to R3 by R4. This is the condition when there is no current from this galvanometer. Means if there is Ig, then this Ig should be 0. This is a balanced Wheatstone bridge condition. Okay, these R1 and R2 are non-resistor, R3 is adjustable, and this R4 is unknown. Okay. So next. So if Wheatstone bridge R1 has 2 ohm, R2 has 4 ohm, R3 has 3 ohm, and R4 has 6 ohm. So what is the balanced Wheatstone bridge condition? R1 by R2 equal to R3 by R4. In this condition, R1 is 2 ohm, R2 is 4 ohm, and R3 is 3 ohm, R4 is 6 ohm. Okay, ratio is on both sides 0.5, 0.5. So both sides ratio is same. It means this is a balanced Wheatstone bridge. So current through the galvanometer will be 0. Got it? So in a closed loop, applying Kirchhoff loop rule, the algebraic sum of all the potential difference across the resistor and cell is 0. This is the statement of Kirchhoff's loop rule, that algebraic sum of all the potential difference across the resistor and the cell is 0. Okay. So also the full statement is sum of potential changes, voltage gains and drops around any closed loop must be 0. Why? Because potential is conservative. Means potential energy is conservative. Okay, so this arises because the electric potential is path independent. It only depends upon initial and final points. If we are in closed loop, we are starting from a point and returning to same point, the potential difference will be 0. Got it? So in Kirchhoff junction rule, the statement which is correct is, according to Kirchhoff junction rule, the current entering the junction must be equal to current leaving the junction. So which is the correct option? First one, the sum of current entering a junction equals the sum of current leaving the junction. So what is the last question? 3 cells with EMF 2 volt, 3 volt and 5 volt, all in series, aiding an internal resistance 1 ohm, 2 ohm and 3 ohm. So they are connected in series. So equivalent internal resistance will be, since they are in series, so equivalent internal resistance will be simply the algebraic sum. So R equivalent will be R1 plus R2 plus R3, which is 1 plus 2 plus 3 equal to 6 ohm, which is first option. Got it? So this is the discussion of your mock test. Those who have not solved can solve now, or I hope you have I have cleared all your doubts. Thank you.